let's talk about polynomials some more. So last class we talked about this particular polynomial, 0.005 times x minus 5 times x minus 10 times x minus 2. Thank you. Times x plus 3 times x plus 7. Oh, right. Thanks. Okay, so there's a lot of vocabulary surrounding the x-intercepts of a polynomial. Sometimes we call them solutions to where the polynomial equals 0. Sometimes we call them zeros. Sometimes we call them x-intercepts. And then we get all of those things by knowing the factors. So we have this advantage of having a polynomial in totally factored form, and that it's easy to solve this equation. You set each factor equal to 0. Right? And then solve each equation. So we get x equals 5, x equals 10, x equals 2, x equals -3, and x equals -7. Those are places where the polynomial equals 0, the solutions to p of x equals 0. Then the zeros of p are those same values, 5, 10, 2, -3, -7. So that's the definition of a 0. It's places where the polynomial equals 0. X-intercepts are places where the graph touches the x-axis. So that happens when x is 5, 10, 2, -3, and -7. And then the factors of p, those are x minus 5, x minus 10, x minus 2, x plus 3, and x plus 7. Those are the factors. So the factor theorem essentially says that these four things are all the same. Places where p of x equals 0, the zeros, the factors, and the x-intercepts are essentially all the same concept. Okay, so if you know, knowing zeros, knowing factors, knowing solutions, and knowing x-intercepts are all the same problem. So I want to use this factor theorem to determine whether or not x minus 2 is a factor of this cubic polynomial. Okay, so if x minus 2 is a factor, what else do I know? It's a 0. Well, what is a 0? 2 is a 0. I know x equals 2 is a 0. Right? That is p of 2 should be 0. That's what it means to be a 0. Okay? So I just have to check p of 2. And if it equals 0, then I know x minus 2 is a factor. So p of 2, if I plug a 2 in there, I'm going to get 8 plus 2 times 2 squared is 8 minus 2 minus 10. That's 16 minus 2 is 14 minus 10 is 4, right, which is not 0. So if p of 2 is not 0, x minus 2 is not a factor. So basically, we use this factor theorem to answer questions that would be difficult, right? To know if x minus 2 is a factor, I would have to actually do some division, right? And I'd rather not. So if I can just plug in a 2, that's easier. So let's use the factor theorem to factor 2x squared minus 3. So if I want to know its factors. If I knew its zeros, then I would know its factors. They're almost interchangeable. So to find zeros, you set the function equal to 0 and solve it, right? So x squared equals 3/2. So x is plus or minus square root of 3/2. So I know it's zeros, which means I must know its factors. 2x squared minus 3 then must factor to x minus square root of 3/2 times x plus the square root of 3/2. So let's see what happens if I want to check it, right? I want to check that x minus square root 3/2 times x plus square root 3/2. I'm going to just FOIL it out and make sure that I get 2x squared minus 3. So when I do first, I get x squared. Outer and inner are the same but opposite signs, so they're going to cancel. And then what is square root 3/2 times square root 3/2? Yeah, 3/2. Square root 3/2 squared is 3/2. But that's not my original. My original was 2x squared minus 3. So this whole thing is off by a factor of 2. I need a 2 in front of the x squared. And if I multiplied the 3/2 by a 2, the 2's would cancel and I'd have the minus 3. So I have to remember to throw that leading term of 2 there. So I end up with 2x squared minus 3. So this is the final factorization. So if you know the zeros, you know the factors. You just have to write down the leading coefficient also. So there's a few different ways we have to find zeros of polynomials. We can use a quadratic formula, but it's only good if your polynomial is quadratic. Only works. You can graph it and have the graphing calculator find x-intercepts. Or you can factor, which is really hard when the polynomial is a high degree. So how would you go about finding the zeros of x squared minus 8x plus 4? Quadratic formula. Good. What if I wanted to find the zeros of x cubed plus 2x squared minus x minus 10? Graph it. Sure, I could do that. It turns out that there is also a cubic formula that's analogous to the quadratic formula. And it's not in here, of course. Yeah. So luckily, we're not ever going to use that. Okay. But I just wanted you to know that there is one, and it's just a nightmare. So graph it. Okay. So instead of using that intimidating cubic formula, we're going to try a graphical / algebraic method. So we're going to start by graphing it, and we're going to see 3 zeros. So pull out your graphing calculator. Okay, so I'm going to graph x cubed minus x squared minus 24x plus 48. And I guess I'll just start with a standard window, zoom 6. And you can see it crosses the x-axis in 3 places. Okay. One of them appears to lie on a nice integer number, right? A nice whole number. And the other 2 are kind of like probably somewhere in between. So which one looks like it has a value right on an integer? A 0 right on an integer. Yeah, the one furthest to the right, and it looks like 1, 2, 3, 4. Looks like it might be on 4. We can confirm by using the calculate 0 option. And we give a left bound. And a right bound. And a guess. And we get 4. Okay, so I have 1, 0, nice, easy, round number. One of my zeros is the 4. So I'm going to use the, right, it was the 0 command on the calculator. And I could use that for the other 2, but it's only going to give me approximate answers, okay, as opposed to exact values. And it only works in this case because I happen to be able to see the other 2 x-intercepts in the window. There could be another one way out at 50, right, that I just can't see. So I'm going to continue trying to figure out what my other 2 zeros are using some algebra. Okay. So since 4 is a 0 of p of x, then what must be a factor of p of x? Close. X minus 4. X minus 4 is the factor. Okay. So here's a little aside. I'm just telling you, 22 is a factor of 2,970. What does that mean if I tell you 22 is a factor of 2,970? It goes into it. What does that mean? Great. So it says, well, somebody said it goes into it, right? So that means 2,970 divided by 22 is some number, some whole number, right? And then, or I could write this alternatively if I like cross multiply that guy, that 22 times some whole number is 2,970. Okay. So I'm going to try to apply this same idea to polynomials. Okay. So if x minus 4 is a factor of that whole long polynomial, then we know that this long polynomial is equal to x minus 4 times some other stuff, right? That's what it means to be a factor. So how do you find that other stuff? How do you find out what that is? Yeah, up here, if I wanted to know what this k was, I would have to divide, right? Divide both sides by 22 to find out what k is. Here, I have to divide both sides by x minus 4. And I'd have my stuff, right? So my stuff, my missing factor, is x cubed minus x squared minus 24x plus 48 divided by x minus 4. So I have to be able to divide that polynomial by x minus 4. Okay, so without a calculator, 2,970 is equal to 22 times what? $135. How'd you get that? Okay, long division. You divided both sides by 22. So 2,970 divided by 22. No calculator, because your calculator can't do long division for polynomials, so we have to remember how to do it. Okay, so we're going to do a long division problem. I know. So 22 goes into 29. How many times? Once. And so you put the 1 over the place value that you're working with, right? Okay. So you do 1 times 22 and you get 22. And you subtract you get 7. Then you bring down the next value of 7, right? And then you say 22 goes into 77 how many times? 3 times. Then you multiply. 3 times 22 is 66, and you get 11. 22 goes, oh, and bring down the 0. 22 goes into 110 5 times, and 5 times 22 is 110, and I subtract and I get 0, so I know I'm done. So the answer is 135. All right, so I just want to point something out. So when I'm looking at 22 into 29, the most important thing I notice is that they both start with 2, right? They're both 20-something, so it can't possibly go in more than once. So the most important thing to look at is the largest place value. When you're trying to decide how many times it goes in, we look at the largest place value. So polynomial division works exactly like long division of numbers, almost. So I'm going to do x cubed minus x squared minus 24x plus 48, and I'm going to divide it by x minus 4. So each exponent, right, each term is kind of like a place value with the numbers, right? So the x is kind of like the tens, and the 4 is kind of like the ones. And my 48 would be ones, and 24x tens, and hundreds and thousands. Okay? So each term is kind of like a place value. So I want to know how many times x minus 4 will go into x cubed. That is what I'm just going to look at the leading term, right? The highest place value is sort of the most important. What should I multiply x by to make an x cubed? X squared. So that's what I'm going to put here above the x cubed. Then I'm going to multiply x squared times the x minus 4. So x squared times x gives me x cubed. And x squared times negative 4 is negative 4x squared. Then I'm going to subtract. Oops. Okay. X cubed minus x cubed is 0, so that goes away. And then I have negative x squared minus negative 4x squared. Negative x squared minus a negative, which would be plus. Yeah, so negative x squared plus 4x squared is 3x squared. Okay? Bring down the minus 24x. Then you start again. You say, okay, x minus 4. I want to know how many times it goes into 3x squared minus 24x. The most important thing is the leading term. So what should I multiply x by to make a 3x squared? 3x. Well, it doesn't really matter. Okay, so 3x times x minus 4. 3x times x is 3x squared. And 3x times negative 4 is negative 12x. And I have to subtract that whole thing. So I have 3x squared minus 3x squared. That goes away. And then I have negative 24x minus negative 12x. Yep, comes out to negative 12x. Bring down the plus 48. Then you say, what do you multiply x by to make negative 12x? Negative 12. Put that up here. Negative 12 times x is negative 12x. Negative 12 times negative 4 is plus 48. Subtract that whole thing. Negative 12 minus negative 12 is 0, and 48 minus 48 is 0. So this, x squared plus 3x minus 12, that's the stuff. So I now know that my polynomial p of x, which is x cubed minus x squared minus 24x plus 48. Well, I knew x minus 4 was a factor, and I got that by finding a 0 on my calculator. And I got another factor by doing division, by doing the polynomial divided by x minus 4 to get the other factor, x squared plus 3x minus 12. So if I want to find all the zeros, I'm interested in where p of x equals 0, right? Because if I want to find all the zeros, zeros are places where p of x equals 0. So I want to know, where does p of x, which is x minus 4 times x squared plus 3x minus 12 equal 0? Well, I have two things multiplied together, and the answer is 0. So either x minus 4 is 0, and x equals 4. I already knew that one, right? Or x squared plus 3x minus 12 is 0. And I can get the zeros to that by doing what? Quadratic formula. So I get x is negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have negative 3 plus or minus the square root of 57 all over 2. Oops, no, that's right. 9 plus 48 is 57. So those are my other two zeros, an exact value, right, which my calculator could not give me. It can only give me decimal approximations. So to get a decimal approximation from the exact value, I could just type it in. So I want negative 3 plus the square root of 57 over 2, 2.27. And negative 3 minus square root 57 over 2 is negative 5.27. So I now have 3 zeros, which means I can write my polynomial as 3 factors, x minus each of my zeros. So my final polynomial is going to be x minus 4 times x minus, and then I'll put my 0, negative 3 plus square root 57 over 2. And then x minus negative 3 minus square root 57 over 2. So just do x minus each of the zeros, and now you have it in factored form. Okay. Before we move on to the next part, I want you to do on the last page the activity factoring polynomials. Just do 1A before we move on. We graphically find that x equals -2 is a 0, right? And if x equals -2 is a 0, then x minus -2 is a factor, right? So we have this relationship between zeros and factors. If -2 is a 0, then x minus -2 is a factor, or x plus 2 is a factor, which means that I could write h of x as x plus 2 times some stuff. That's what it means to be a factor. To find out what the stuff is, I have to do long division. I'm going to have to do x cubed minus x squared minus 5x plus 2 divided by x plus 2. And what I come up with is going to be that stuff I'm looking for. So you say, okay, well, x, what do I multiply x by to make an x cubed? X squared. X squared times x is x cubed, and x squared times 2 is 2x squared. And then I have to subtract. And I always put parentheses to remind me that I have to subtract both terms. So I get x cubed minus x cubed, which is 0, and then negative x squared minus 2x squared, which is what? Negative 3x squared. And then bring down the minus 5x. Then you say to yourself, okay, x times what will give me negative 3x squared? There we go. X times what will give me negative 3x squared? Negative 3x. Then you multiply it. Negative 3x times x is negative 3x squared. And negative 3x times 2 is negative 6x. And then you subtract. Negative 3x squared minus negative 3x squared is 0. And negative 5x minus negative 6x is what? X. Then you bring down the plus 2. And x plus 2 goes into x plus 2 how many times? Once. What do I multiply x by to make x? A 1. And 1 times x plus 2 is x plus 2, which is 0. So I have x squared minus 3x plus 1. So I now know h of x is equal to x cubed minus x squared minus 5x plus 2. And I can factor it to be x plus 2 times x squared minus 3x plus 1. So to find the other two zeros, I can set, to find all the zeros of h of x, I'm going to set it equal to 0, right? I already know x plus 2 equals 0, gives me a 0 at negative 2. So I'm just going to solve this one. X squared minus 3x plus 1 equals 0. And I use the quadratic formula. So I get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 3 plus or minus the square root of 5 over 2. So those are my other two zeros, which means I have two more factors, right? X minus one of these and x minus the other. So my final factorization is going to be x plus 2 times x minus times x minus, and then I'm going to put in my other two zeros, 3 plus root 5 over 2, and 3 minus root 5 over 2. So that's my completely factored form.
It's always x.
Yes. It's always x minus a 0, whatever the 0 is that you have found. Yep, so I can write that down even. So if c is a 0, then x minus c is a factor, regardless of the sign of c, right? Whatever the 0 is, you just do x minus that thing, and you get a factor. Nope, that's because the 0 was -2. So when we used the calculator, we found out that -2 was a 0. So I did x minus -2, right? Which became x plus 2. All right, so let's go back. So the last thing we have to talk about is the multiplicity of zeros. This is something that you're going to need to know for your project. Okay. So here's a polynomial, 0.01 times x plus 3 squared times x minus 2 cubed times x minus 4. So if I want to find its zeros, I have to set each factor equal to 0. And if I write this all out, this actually says 0.01 times x plus 3 times x plus 3 times x minus 2 times x minus 2 times x minus 2 times x minus 4. Right? Because x plus 3 squared just means x plus 3 times x plus 3. And x minus 2 cubed means x minus 2 times x minus 2 times x minus 2. So if I write it all out, those are all my factors. And then the process of finding zeros says take each factor and set it equal to 0, right? So I'm going to end up with my zeros are x equals -3, -3, 2, 2, 2, and 4. That's what I get when I set each factor equal to 0. It's a little weird to say that -3, to put -3 in the list twice, right? So what we do instead is we say, well, -3 is a 0 that has multiplicity 2, because it was a factor twice. And we say 2 is a 0 of multiplicity 3. And we say 4 is a 0 with multiplicity 1. So when a 0 has odd multiplicity, 1 or 3 or 5 or 7, it crosses the x-axis. So for example, 2 and 4 both had odd multiplicity. So at 2 and at 4, the graph actually went right through, from above to below or below to above. It crossed through the x-axis. But when you have even multiplicity, the graph will touch the x-axis but not cross. Like with -3 that had multiplicity 2, right here, it touches the x-axis but doesn't cross, like bounces off. And when your multiplicity is greater than 1, the graph gets flatter near the 0. Okay, so here for 4, it had multiplicity 1 and it just went straight through like a line. And for at x equals 2, it had multiplicity 3 and it went through the x-axis, but it flattened out kind of on the way through. So one way to kind of remember the multiplicity rules is to zoom in on the zeros. And we'll see what that gets us. I need my zooming tool. I gotta remember how to do this. Is it that? No. Okay, so I'm gonna zoom in on the zero that has multiplicity 1, x equals 4. It's just a 0 one time, it has multiplicity 1. If I zoom in on it, that didn't work. So you zoom in on it, and it just looks like a line going through the x-axis. So multiplicity 1 just looks like a line. So maybe I'll zoom in on it even a little bit more. Straight line. When I zoom in on the multiplicity 2, the x equals -3, what kind of function does that look like? Parabola, or x squared, right? So multiplicity 2 looks like a quadratic. Multiplicity 1 looks like a line. What do you think multiplicity 3 is going to look like? A cubic, x cubed. So let's zoom in on here. And that looks almost just like x cubed. So the multiplicities tell you the local behavior of the graph at the 0. It'll look like the type of function that has that degree. All right, so here is a polynomial, graph of a polynomial. I want to write a possible equation for this thing. So what are my zeros? Where do I cross the x-axis? Just the x values, not the factors. Just what are the zeros? -2. Where else? 0 and 1. So now I have to decide their multiplicities, right? Now I have to decide what their multiplicities are. So if I zoom in on the -2, what kind of function does that look like? A cubic, which means it's probably multiplicity 3. Okay, and then let's zoom in on the 0. What kind of function does that look like? A line, which would be multiplicity 1. And then if I zoom in on the last 0, the x equals 1, that looks like quadratic, which would be multiplicity 2. Okay. So if I write this out in factored form, an equation for this guy would be, we'll call it p of x for polynomial. X equals -2 is a 0 3 times, which means that x plus 2 is a factor 3 times. And x minus 0 is a factor once. And x minus 1 is a factor twice. So to condense this a little bit, I would write p of x equals x plus 2 cubed times x minus 1 squared. No. Nope. That's a good question, but it so at the -2, it looks like a cubic, but with the opposite end behavior, right? But it doesn't. All that the fact that it looks like a cubic tells us is that it's multiplicity 3. You don't have to do. It doesn't tell us any other information. All right, so now that we're through the rest of the lecture, I want you to go and do the rest of this activity.